In this video, we're looking at lesson 10, which is second and higher order derivatives. We'll also be trying to squeeze in the product rule as well. That'll be in the next video. So second and higher order derivatives, you are basically differentiating again and again. And the reason we do this is something to do with the double derivative test, which helps determine if something is a minimum or a maximum, or like the nature of stationary points. And we've got some ways of describing how to do this notation. So it's pretty straightforward, really. Let's pretend you've got 2x to the 5 dy by dx. That's the gradient function, is 10x to the 4th. We already know how to do that. And this one is the 40x cubed. You just differentiate once more. Now, first thing you may know, what actually is this? This is the change in gradient. So it's like, how is the gradient changing? Is the gradient increasing? Is the gradient decreasing, basically, at any point? So that's what this function helps shows us, and it's links in with our concept of concavity. Now, the process can continue if you so wish. You can differentiate once more. It becomes d cubed y on dx cubed. So did you notice that notation? There's a squared here, and I'll highlight it here. The square goes here, and the square goes here, because you're differentiating once more, okay? And if you do it again, it's going to be d cubed on dx cubed, and you notice that again. So that's our notation we use. If we're using dash notation or prime notation, it goes 1 dash, double dash, triple dash, etc. Okay, so now let's have a go at these examples. I'm going to do the first one, then you pause the video, have a go at this one, and keep going. So find the double and the triple derivative. Okay, so I'm going to use our dy by dx notation. 15x to the 4, d squared on dx squared, 60x to the 3, and then we have our last one, which is d yeah, that looks good. D cubed on dy dx cubed, and that becomes 180x squared. So that's all we have to do here. So pause the video, have a go at the one on the right, and then play when you're ready. Okay, we're going to go through the answers. So dy by dx you should have as negative 8x cubed, d squared y on dx squared is negative 24x squared, and d cubed y on dx cubed, or d cubed y by dx cubed is going to be negative 48x. Hopefully got that well. Next step is we need to evaluate this function here. I'm going to rewrite this as bring everything to the numerator. So remember, if you've got something in the denominator, like an unknown, bring it up to the numerator. It just makes life easier. We want to double differentiate and find when x is equal to 3. So what's the change in gradient when x is 3? So here we go. F of x, or f dash of x, is going to be negative 2, take 1 off, so it's negative 2. Then we differentiate once more, and we notice the negative changes back to a positive again for x to negative 3. Next step, I can write it like this. It's always handy to write in that form if we're subbing in values, and now we're going to plug in that value of 3. So this becomes 4 on 27. And there we've answered that question. What I want you to do is have the go on the one on the right, and then basically press play. When you're ready, here we go, through the answers. F dash of x is equal to, and 3 on 2 times 6, well, it's going to be 9x take 1 half. F double dash x is going to be 9 on 2 x the negative half. Let's rewrite this as 2 square root x. Okay, now let's sub in our value. We've got 9 on 2 square root 4, which is 9 on 4. Okay, hopefully went well there. Now, questions we'll be doing based on this here, if you look up, it's going to be, sadly, Unit 3, Exercise 1A. and just working through the left-hand side for these. Okay. Now, in the next video, we're going to be looking at something called product rule. Hopefully, oh, hang on, we have more derivatives. My bad. Sorry, we have one more thing. More double derivatives. Find the coordinates of any points in the curve where the second derivative has a value of 24. Okay. So second derivative. So let's find that second derivative. Y dash is equal to 6x squared. Y dash dash is equal to 12x. And let's make it equal 24. X is equal to 2, and now we need to sub into our original function, and let's change that to green to find that now. 2 lots of 2 cubed, and that's going to be 16, and it says what's the coordinates, so there's our answer. What I'd like you to do now is have a go at the one on the right, pause, and then press play when you're ready to go. Here we go, let's see what we've got. F dash of x is going to be 3 on 2x squared. F double dash on x is going to be 3x. And now we need to find out when f double dash is equal to 6. So you go 6 is equal to 3x. X must be 2 again. Subbing in gets us 2 cubed. 2 cubed is 8. Half of that is 4 coordinate at 2, 4. Hopefully you found this video useful. In the next video, we'll be looking at the product rule. Thank you very much.